Hey guys, how are you today? I hope you're doing well. We're going today to be continuing with stoichiometry. On Friday, we learned how to convert between moles and particles. We used the conversion factor that 1 mole is equal to 6.02 times 10 to the 23rd particles. And again, those particles can be atoms, molecules, or formula units, just depending upon which type of matter we're talking about, whether we're talking about an element, a molecular compound, or an ionic compound. Again, what is important is not really what type of particle we're talking about, but that conversion factor, that 1 mole of any of those particles, of any of those types of matter, would be 6.02 times 10 to the 23rd particles of that matter. Okay, so today we're going to be talking about volume. And you guys, there's two things that we can use to convert volume to moles or moles to volume. And again, when we're talking about volume here, we're mainly going to be talking about liters. Okay. One of those things that we can use to convert between moles and volume or volume and moles is molar volume. And the second thing that we can use to convert between moles and volume or volume and moles is molarity. When we're talking about molar volume, we're going to be talking about the volume of a gas. And when we're talking about molarity, we're going to be talking about the volume of a solution. So again, it depends upon whether we're talking about a gas or a solution as to which one of these we would use. So we're going to go ahead and talk about molar volume first and do a few practice problems with that, and then we will talk about molarity. So what is molar volume? Molar volume is the volume of 1 mole of a gas at STP. Okay, so again, I made that capital because we're talking about gases here. And then the other thing is that it's at STP. Well, what is STP? Okay, well, STP stands for standard temperature and pressure. Okay, and just for the sake of knowing, standard temperature is 0 degrees Celsius, and standard pressure is 1 atmosphere of pressure. And ATM just stands for atmosphere. So basically, you guys, like the pressure that's on you right now, due to all of the atmosphere, all of the gases, everything above you that's pressing down on you, is called, the amount of pressure that's on you right now is 1 atmosphere of pressure. Again, this pressure is just the pressure that we are experiencing on our bodies right now because of the atmosphere, the gases and everything in the atmosphere above us. Now, why don't we feel like we're under pressure? Well, because it's been there since the day we were born. We're used to it. So we don't notice that pressure. But, you know, if we were to go to outer space, if we'd been born in outer space and lived in outer space where there's not as much pressure, then when we came to Earth, we would feel very heavy. Okay. Because of all the atmospheric gases pressing down on us. So again, standard temperature and pressure is 0 degrees Celsius and 1 atmosphere. And that really doesn't matter for our intents and purposes here and what we're doing, but I wanted to explain it to you. So again, whenever we're using the factor label method, which we are going to be using, we have to have at least 1 conversion factor. So we need to know what is the conversion factor for us to convert between volume and moles or moles and volume. Again, liters is what we're using for volume. So liters and moles or moles and liters. And that conversion factor is 1 mole is equal to 22.4 liters of a gas at STP. Okay? So again, whenever we're looking at a problem and we see that it's talking about STP, standard temperature and pressure, we know that it's talking about a gas. And so we know this is the conversion factor that we're going to use. So again, guys, the way that I remember to use this conversion factor is that STP. That STP will be in the problem, and that tells me I need to use this conversion factor. So here on the notebook, the interactive notebook for today, there are a couple of slides for you to do where you're going to just do it, 2 or 3, 4 practice problems using that conversion factor. 1 mole is equal to 22.4 liters of a gas at STP. So we're not going to do those problems that I have assigned for you to do. I'm going to do just a couple of practice problems that are going to be very similar to the ones that you're going to do. And then when we finish that, don't forget we are going to also be talking about molarity. So you're not done. We're going to have more to do. So let's go ahead and look at the practice problems for molar volume first. So the first one we have here, notice this is more like a word problem, but it doesn't matter. We're going to do it the same way that we've been doing all of our factor label problems up to this point. So our problem says a cylinder contains 15.85 moles of nitrogen gas at STP. So you guys, when I see that STP, I know. And also it tells me gas. It tells me a gas at STP. So I know the conversion factor I'm going to use. I'm going to use 1 mole is equal to 22.4 liters. Okay, I already know that's what I'm going to use because that problem says gas at STP. I know this is the conversion factor that I'm going to use. So it gives me 15.85 moles. And it asks me what is the volume in liters. So again, I know I'm solving for liters here. So I'm going to take what I'm given and put it over 1. 15.85 moles over 1. Then we're going to set up our next ratio. Again, I know I don't want moles, I want liters, so I need to cancel moles out. So if moles is on the top here, I need to put it on the bottom so that it will cancel out in this next ratio. Okay, the next thing I'm going to do is put the unit that I'm solving for on top, which is liters in this case. Okay, now once I have this set up so that my units will cancel, moles will cancel, and I will be left with liters, now I'm ready to get the numbers from the conversion factor. So again, whatever number is in front of the unit in the conversion factor is the number that goes in front of the unit in your problem. So in the conversion factor, 1 is in front of mole. So in my problem, I put 1 in front of mole. In the conversion factor, 22.4 is in front of liters. So in my problem, I put 22.4 in front of liters. Now I'm ready to solve because I have canceled out the unit I was given and I have arrived at the unit that I'm solving for. So I'm going to multiply across the top, multiply across the bottom. So on the bottom, I can already see there 1 times 1 is 1. On the top, I need to multiply 15.85 times 22.4. So punch it in my calculator, 15.85 times 22.4. And that gives us 355.04. So going back to our problem, 355.04. And again, my only unit that I haven't canceled out is liters. So 355.04 divided by 1 is 355.04 liters. And that's my final answer. Okay? So these are not difficult at all. Let's look at the second one. A tank is filled with Ne, that's neon gas at STP. So again, I see gas at STP. I know my conversion factor is going to be 1 mole is equal to 22.4 liters as soon as I see that gas at STP. Okay, the tank has a capacity of 18.0 liters. So that's my given information. That's the only number that I'm given, 18.0 liters. How many moles? So I know moles is what I'm solving for. So I'm going to take what I'm given and put it over 1, and I'm going to be solving for moles of neon in this tank. So 18.0 liters over 1. Now, I know I need to set this up so that I get rid of liters. I need to cancel out liters and solve for moles. So liters is on the top here, so it must go on the bottom here so that it will cancel out. And the unit that I'm solving for is moles, so moles goes on the top. Okay, now that I have my unit set up so that liters will cancel, I'm ready to use my conversion factor. 1 is in front of the mole in the conversion factor. 1 goes in front of mole in the problem. 22.4 is in front of liter in the conversion factor. 22.4 goes in front of liter in the problem. Now we're going to multiply and divide. So multiply across the top. 18.0 times 1 mole is 18.0 mole. On the bottom, 1 times 22.4 is 22.4. Now we're going to divide. 18.0 divided by 22.4. So 18 divided by 22.4. And that gives us, and again, we're going to just do 2 places past the decimal here. So 0.80. Again, the 3 behind the 0 does not change the 0. It would have to be 5 or greater for us to round that 0 up. So we're just going to put 0.80. So this is 0.80 moles. Okay, and that will be our final answer. All right, so now we are going to go look at molarity and do a couple of example problems with molarity. So we got a couple of questions to answer here first. What is molarity? Molarity is the concentration of a solution is what it's referring to. And it is given in the number of moles in 1 liter. Okay? So again, the molarity is the concentration given in the number of moles in 1 liter. So how can we use it? Well, we can use it to convert between moles and liters for solutions. As I said earlier, the molar volume is for gases at STP. For the molarity is for solutions. Okay, so how can the molarity be rewritten as a conversion factor to convert between liters and moles? Well, how we can do this is if we know it's the number of moles in 1 liter, then what it tells us is that the number of moles, whatever that number is equal to 1 liter. Okay, kind of like density. We said that, a density of 2.5 grams per milliliter means that there's 2.5 grams in 1 milliliter. Well, here, if we say the molarity is 2 molar, then that means it's 2 moles in 1 liter, which means 2 moles is equal to 1 liter. And we'll look at that here in just a minute. So again, you guys, here, the molarity is our conversion factor. Just like the density can be used as the conversion factor, okay, here with molarity is the conversion factor. Molarity is the conversion factor. So I'm going to show you a couple of examples on how to do this, and then you are going to have 4 examples here again, 2 slides with 2 problems each. And just like we've been doing since we started Unit 6, the factor label method, you are going to work these problems out on a piece of paper. Work both of these out on the same paper together. Take one picture and insert it into the slide here. Do that for every one, all of these 4 slides that have problems on them. Okay, so we have 2 example problems here that we're going to use, and I'm going to show you how to use that molarity as your conversion factor. So let's go ahead and look at the first problem. How many moles are in 2 liters of a 6 molar hydrochloric acid solution? So guys, here notice that we are given 2 numbers. One of these is our given. The other one is our molarity, which is our conversion factor. So when we see this 6M, guys, that's our molarity. If you go back and look, okay, our molarity is a capital M. So when you see that capital M, you know that that is your molarity. That is your conversion factor, okay? So then that means that this 2 liters is our given. So we're going to go ahead and take that given information and put it over 1 like we always do. Same step. Okay, and then we want to cancel out liters, so we're going to put liters on the bottom. Notice we are solving for moles, so we're going to put moles on the top because that's what it's asking us to find. So how many moles? That means moles is what we're solving for. The 2 liters is our given, so we put it over 1 and then set it up so that liters will cancel. Now we're ready for our numbers, and so that's where we're going to go do this conversion factor. So you guys, 6 molar is the same thing as 6 moles in 1 liter. Okay, and so now that we know it's 6 moles in 1 liter, well, you guys, that's our conversion factor. Just like 2.5 grams per milliliter for density means that 2.5 grams is equal to 1 milliliter. Well, 6 moles per 1 liter means that there are 6 moles in 1 liter of this solution. Okay, so this is our conversion factor. There are 6 moles in 1 liter. So now we can plug in our numbers. 6 in front of moles in our conversion factor, 6 in front of moles in our problem. 1 in front of liter in our conversion factor, 1 in front of liter in our problem. Our liters cancel out. And on the top, we have 2 times 6 moles, which is 12 moles. On the bottom, we have 1 times 1, which is 1. When we divide, 12 divided by 1 is 12. So the answer is 12 moles. Again, you might have been able to figure that out just by looking at this, but again, that won't always be possible. So again, I will expect you to use the factor label method to do all of these problems, and if you don't, I'm going to return your work and tell you you need to do it again. All right, so let's look at the second problem. You need 2.3 moles of NaCl in a 3 molar solution. How many liters of solution will you have? Okay, again, I have two numbers here, 2.3 moles, and I have 3 molar. Remember that capital M is molar, so that is our conversion factor. So then this 2.3 moles is our given information. So we're going to put it over 1. 2.3 moles over 1. Now we're going to set it up so that moles will cancel, and we're going to solve for the unit it's asking us for. It's asking us for how many liters. So again, moles will go on the bottom, so it will cancel out. And we're going to put what we're solving for on the top, which is liters. Okay, now that we have it set up so that moles will cancel, we need our numbers. That's where we're going to use this conversion factor. So we have 3 molar. So 3 molar for this solution means there are 3 moles in 1 liter of this solution. So what that tells us is that 3 moles is equal to 1 liter for this solution. So that is our conversion factor. 3 moles is equal to 1 liter. So now we have our conversion factor. We can substitute the numbers into our problem. 3 in front of moles in the conversion factor, 3 in front of moles in our problem. 1 in front of liter in the conversion factor, 1 in front of liter in our problem. Now we're going to multiply and divide. Multiply across the top. 2.3 times 1 liter is 2.3 liters. On the bottom, 1 times 3 is 3. Now we're going to divide. 2.3 divided by 3. 2.3 divided by 3. And that gives us, again, we're going to do 2 places past the decimal, so 0.76. This next 6 behind that, the first 6, we'll round this second 6 up to a 7. So this will be 0.77. So 0.77 liters will be our final answer. And that's all there is to it, guys. Again, you're just converting between moles and liters and moles. The only thing you have to determine is which one of the conversion factors do you use. If you're given the big M, molarity, then that is your conversion factor. If you are given, if you are told gas at STP, or even if it just says STP, you know that you're going to use molar volume as your conversion factor. 1 mole is equal to 22.4 liters. You guys, please let me know if you have any questions. I've had several students that have asked me for tutoring for different reasons. It could be to retake a test. It could be to retake your ACT quiz from Friday. It could be to help with some of this factor label method and these conversions. If you need help, then I invite you to email me, and we will set up a time for tutoring on Google Meet. And I will Google Meet with you, and we will go over things one-on-one, and I will help you to understand if you're having issues, or we will go over things that you missed on a quiz or test and let you retake a quiz or test so that you can improve your score. So please, please contact me. If you have had an assignment where I have invited you to email me about a Google Meet for tutoring, then that means that you really need it. You know, if I've commented that on one of your assignments that, contact me for tutoring, that means you really need tutoring because you didn't understand what you were doing in the lesson. And so, I'm available. You just email me, and we will set up a time for you to do some tutoring with me on Google Meet. Again, please let me know if you have any questions. Have a great day. Bye-bye.